Hello everybody, welcome back. Today we're going to be looking at Chapter 7, Section 4. We're going to be using substitution strategy to solve a system of linear equations. So when you're asked to solve a system's linear equations algebraically, you use one of two methods. Today we're going to look at substitution in 7.4, and then we'll look at 7.5 in our next section where we use a strategy called elimination. So substitution is exactly how it sounds. We substitute one of the variables into the equation to satisfy the system, solve for one of the variables, and then substitute it back in to solve for the next. So if you look at these, well, first what we do is we call them equation 1 and equation 2, right? So we know which ones we're referring to. So we call them equation 1, equation 2. Okay. Next, what we want to do is we want to solve one of these equations and set it equal to a single variable. So obviously there's a coefficient in front of every variable except for this y. So what we're going to do is we're going to set this second equation as y. So we're going to leave the first one alone, but the second equation we want to do is we want to set that equal to y. So we're going to rearrange the formula for y. So it's going to end up as y equals 5, and then we put the 4x on the other side, and in doing so, obviously, we have a subtraction symbol, right? Because it was positive on the right-hand side, or sorry, positive on the left-hand side, so when we bring it to the right-hand side, that's going to make it subtract 4x, okay? So that's what we want to do there. All right? So now, everywhere we see y in the first equation, we're going to substitute in 5 minus 4x. Because if y is equal to 5 minus 4x, then this y, we can substitute it in, and then we'll only be left with the x variable. That is the goal. All right? So that's what we're going to do now. We're going to substitute in that equation into equation 1. Okay? So we'll substitute this into equation 1. So we rewrite equation 1. Okay? Rewrite equation 1. Everywhere we see y, we're going to substitute in the 5 minus 4x. So we'll copy. Now, of course, there's a 4 in the front, so we got to put brackets around that. The 4 will have to be multiplied by not only the 5, but the 4x as well, as we did in the past, right? Okay? Now we're going to use the distributive property, take the negative 4, and it's going to be multiplied by 5 and multiplied by 4x. So we'll take that, we'll recopy it, and we'll work through that. So that'll be negative 20. And then the negative 4 times negative 4x would be plus 16x. And that'll be equal to 7. So now we're going to collect like terms, and anything that's not with the variable x will go to the right-hand side. So the 16x and the 2x will be added together. And we get 18x. Then the 20, we're going to add it over to the other side, so it's going to be plus 20. So that'll be gone. So we're left with 18x is equal to 7 plus 20. Right, so we'll add them together. And we get 27. We divide both sides by 18. And we get x is equal to 1.5. Okay, or 3 over 2 is fine. 1.5 or 3 over 2. So there's our x variable. So this means that these two linear lines intersect at the x value of 1.5. Okay? Now we want to get the y value, so you can plug it into either of the two equations. So I'll substitute it in the second equation. Okay. So now we're going to solve that. So everywhere we see x, we put in 1.25. 1.5, sorry, I don't know why I said 1.25. All right, multiply 4 by 1.5, and we get 6. Subtract the 6 from both sides. subtract 6 from both sides, so minus 6 minus 6. So y equals, and we add them together, and you get negative 1. So your solution to the question is, I like to call it a coordinate, so we get a real understanding. So the coordinate would be 1.5 and negative 1. And there's your solution, because it's an intersection point between the two lines. Okay? That is one method that we can do. All right? So substitution is substituting one equation into the other, solving for one variable, and then you resubstitute that into either of the other two equations. It would work for both. I'll show you that as well. So you can see that it's not only for one equation, it would work for both. It has to work for both, right? So again, I'll substitute that x value in here, 1.5. Because I know some of you are saying, oh, why didn't you put it in the other equation? You can't. You can put it in either one. Okay? And 1.5 times 2 is 3. And then you subtract 3 from both sides. Right? Get rid of that. We subtract the 3 from both sides. Put a positive 3 here. Subtract 3. So now we just take the 7 and subtract the 3. We get 4. Divide both sides by negative 4, and you would get negative 1. Again, the same solution, obviously. So there is just a check. You can put it in equation 1 or into equation 2 and end up with the same result. Okay? To verify, you would just take the 2 points, the x and the y, and you can plug them both in and make sure the 7 is equal to the 7 if you're asked to verify. Okay? Another way, which is kind of neat, I'll just show you quickly, is if we put these two equations in Desmos, you'll see the intersection point of the two. And this really, it's kind of like what we did yesterday. So I'm going to click on Desmos.com. Okay? I'm going to put in those two equations. So the first one was 2x minus 4y equals 7. There's that linear line. And the second one is 4x plus y equals 5. And you'll notice that there's an intersection point at x equal to 1.5 and y equal to negative 1. So that's what you're solving for when you're doing a 2x2 system. If you have two linear lines, and what will happen is they'll intersect at one point. They could intersect at none. That would be the case if you had two parallel lines. And there's another case where you have an infinite number of solutions. That's if the lines or the equations are equivalent, so they land right on top of each other. But the majority of the time, you will end up with one intersection point between the two, and there it is. We verified it another way using our calculator. Now, if we want to use our Desmos program, if we wanted to verify using a calculator, what you would need to do is you would have to rearrange both formulas and put them into slope-intercept form. So by doing that, that would take the 2x over here, so it would be minus 2x plus 7, right? That would get rid of the 2x, and then I would divide each by negative 4. So if I divide that by negative 4, okay, that's gone, and then I divide this by negative 4, divide the by negative 4, there we go. And again, we can simplify that. That would end up being 1/2 x minus 7/4, right? So I just rearrange the line, same line. And then the same with this one, we just take the 4x over. So it's going to be a negative 4x plus 5 again, and the two intersection points are the same. So the equations would have to be in y equals form. You would just rearrange them like we did in chapter 6 in order to put them in your graphing technology. Okay? And that's it for example 1. Using substitution. So we're going to do some more of those. There's a check your understanding question. You can do the same thing I did there. You'll notice that in the check your understanding, the both of them have a coefficient in front of the y, so you can just divide it through and have it set the y equals. This is really set up for elimination. You're going to learn when we start the next section, but they want us to be able to look at both methods to do both. All right. So that's it for this video. In the next video, what we will do is we'll start example 2, creating a linear system, and then going from there. Okay? All right, thanks everybody, and we will talk again soon.